Hello, my dear students. Good morning. Hope so you all are fine and enjoying these digital classes. So, welcome to the second topic of today's class. That is Haesenberg uncertainty principle. So, as we have studied in the previous video, dual behavior of matter. So, these two principles has somewhere failed the Bohr's model, as that time Bohr's model was the one of the remarkable change, more remarkable model, and brought revolution. So many things cleared after Bohr's model, but still there was some doubt, some limitations. So these two theories has made that model little bit fail. So as we have seen that according to de Broglie relationship, a microscopic particle such as an electron has both wave and particle character. In 1927, Werner Haesenberg, a German physicist, pointed out that we can never measure simultaneously the exact position and the exact moment of a microscopic particle which are as small as electron, which is known as Haesenberg uncertainty principle. So before going to go for this definition, meaning, let's understand Haesenberg uncertainty principle. So Werner Haesenberg, German physicist, in 1927, uncertainty given as a principle which is told about the not fixed. What is not fixed? The position or the momentum. These are not the fixed. So from where this Haesenberg uncertainty principle came? It came from limitation of Bohr's model, and de Broglie equation is also that proved the dual nature of matter, and Haesenberg proved that it is not possible to measure. It is not possible to measure. Try to understand again. It is not possible to measure simultaneously the position and the momentum of a microscope particle with absolute accuracy and certainty. So dear students, here I want to give you one resembling example from daily life, that is during Diwali. When you are playing Diwali, you are playing crackers. So one chakri name is there. Chakri you played I think so many times. So when we are burning that chakri, that is continuously moving like this way in one direction, and with the movement of that chakri, it is moving in a particular space also. Okay. So now here I want to ask you, when this chakra is playing, so can you measure its speed? Okay, if you can measure the speed. So simultaneously, can you measure the position also, where it is? So you can take the example of lattu also. This kind of lattu is there in junior class we were studying. That is lattu, which will revolve around the around anywhere. Yeah, any object which is revolving on the surface of Earth. So it is very difficult to measure the speed of that object as well as the position of that object. If you will see, okay, I can measure the speed, but position also I can see. If you will see this time it is here, so by moving it can reach here. The moment you will say it is here, so it can move from here and it can be somewhere. Okay, so that's why the electron is moving around the nucleus continuously. That is also it is not possible to measure simultaneously that position of that electron and the momentum of electron. So this was the main focus of this principle. It is also stated that the product of uncertainty in position and in momentum of a microscopic particle is always constant and is equal to the greater than h upon 4 pi. This is the mathematical value. So what is delta x dot delta p? Delta x is wave nature, delta p is momentum. So delta x and delta p is greater than h upon 4 pi, only then it is possible to measure. So delta x is uncertainty in measuring exact position, and delta p is uncertainty in measuring the exact momentum of velocity. Okay, so there are three relationship from this equation. It becomes three relationship. First is that if the value of delta x means change in position, is very small, then position can be measured. Yes, then we can measure the position. Position is very small, mean very slow. Then we can measure the position, but momentum cannot be measured. But second case, if the momentum is very small, then we can measure. As speed is very small, so we can measure, but position cannot be measured. But if delta x is 0, value of delta x is 0, the position can be located, absolute accuracy. We can find out it's with the full accuracy, but momentum or velocity cannot be measured at all. So what significance come from these three relationship? Shorter the wavelength, the greater will be accuracy in measuring the position. Yes, shorter the wavelength, I hope so you are getting what is the wavelength. Shorter the wavelength, the greater will be the accuracy in measuring the position. We cannot see a microscopic particle like electron without disturbing it. Yes, this thing they have found with the help of this one theory, that is one example you can say. The moment incident of photon of light fall on electron, so we can see the initially path of electron is like this around the nucleus, but the moment we are providing external energy, external light, external heat, the electron is distracting from its original path, and a new path of electron after impacting with the photon, it means that we disturb the location of electron. So by disturbing the location of electron, we can find out the microscopic particle. We can see the microscopic particle. Okay, but there are some reasons for failure of Bohr's model also. Like first is de Broglie equation. He represented the dual nature of electron and uncertainty principle, both dual nature of electron and uncertainty principle, two theories according to which the exact position of momentum of electron cannot be determined. Now according to this theory, exact position or momentum of electron cannot be determined simultaneously, but as we studied in according to Bohr's law, it revolved in a fixed path which is called orbital around the nucleus, whereas according to uncertainty principle path, it is traced by electron is only probable, not exact. Second, some curiosity is there in the student minds also sometime. Why electron cannot exist in the nucleus? Although proton and neutron are there in nucleus, but why third subatomic particle is not exist in nucleus? So there is very simple reason. Only those particles can remain in the nucleus whose velocity must be less than the light velocity of light, that is 3 into 10 raised to power 8 meter per second. But after calculation the electron velocity, it found that electron velocity is 5.8 into 10 raised to power 10 meter per second. Because of that, electron cannot exist in the nucleus of atom, as it is the part of extra nuclear portion around the nucleus. Because why? Reason again why electron cannot exist in the nucleus: because the speed or velocity of electron is more than the velocity of light. So because of that, the electron cannot exist in the nucleus. Okay, so dear students, quickly recapitulate, as we have done dual nature of the matter, which came from de Broglie equation, in which we studied that the matter can behave like wave, as well as all the microscopic particle which is moving around the nucleus is behave like a wave as well as particle. Second, Haesenbergs uncertainty principle, where we studied that uncertainty, not fixed. So it is not possible to measure that simultaneously the position and the momentum of microscopic particle with absolute accuracy or certainty. Only we can find out it absolute accuracy and certainty if the delta x is 0. Okay, so these are the three relation. Basic relationship of de Broglie was lambda is equal to 1 upon lambda is equal to h upon mb. So here Haesenberg is delta x point delta p greater than h upon 4 pi. So this is all about today's videos. So hope so you understood both the concept. Once again, go through the PDF file, go through this video 2-3 times, try to understand. One more video I will share to help you guys to understand the concept in better way. But most important is self-study. Until you will not do self-study, these kind of videos are not reliable for you, or relevance for you to give you the proper knowledge about the concept. To study the concept, you need to go through 2-3 different medium, different mode. Even you can try yourself also from different way. Okay, now most important, now every student will make, you will speak, you will say something about these two topic. You will make 2-minute 3-minute video and you will share it to me on my personal number, so then I can see how you understood the concept. This is very important. This is your homework. You watch the video, understand the concept, go through the PDF and try to make yourself revision video, a summary of this topic, then do share it to me, then I will comment on your video. Okay, so thank you for watching the video. And once again, dear students, as always I am telling, I bless Almighty God. Maybe you will remain safe and healthy at home. Take care, stay blessed, stay happy. Okay, thank you.